Welcome everybody to another logic video. In this one, we are going to be learning symbolization for truth tables. These are the different parts of the video, and I will put timestamps down below. So first, we're going to be looking at truth tables as a method for determining validity and invalidity. Next, we're going to look at atomic versus compound statements. We're going to finally get to the symbols because we're symbolizing for truth tables. And then we're going to look at 4 things that you should be aware of when you are symbolizing for truth tables. We're going to look at stylistic variants of the different types of statements and logical operators. And finally, we're going to do some practice. So that's where I'll go through some practice problems from the exercises, which will be similar to problems that will be on the exam. All right, let's jump into it. So first, truth tables as a method. We've already seen a few different methods of determining validity or invalidity of arguments. We've seen famous forms. However, there's weaknesses with all of these. So famous forms weakness, there are arguments that don't have famous forms, but they're still valid. So there's only so many forms that you can memorize and categorize. These are our famous valid forms, but arguments come in all kinds of forms, and many of them are valid without having one of those famous valid forms. So that's a weakness. A second weakness of our famous forms method is that it doesn't have a way of showing that an argument is invalid. It is just a way to show that an argument is valid. The second method we learned, counterexample method, resolves that because it's a method for showing that an argument is invalid. Of course, a weakness there, it's not a way of showing that an argument is valid. There's also a weakness in that you're limited by your creativity to be able to come up with a counterexample to an argument. Just because you can't come up with a counterexample doesn't mean that the argument is in fact valid. You might just not have been able to think of a good counterexample. Then we looked at the Venn diagram method, and the Venn diagram method is great because it can show validity and invalidity of arguments. However, one big major weakness there is that it only works for categorical arguments. It doesn't work if your argument isn't categorical. And in fact, many arguments are not categorical, maybe even most. So that's a major weakness there. That brings us to the new method that we're going to be learning, and that's the truth table method. The truth table method is very powerful. It allows us to determine whether an argument is either valid or invalid. So it has that going for it. Now, in order to learn the truth table method, one of the things we're going to need to do is be able to symbolize arguments in order to make this truth table method work. So that's what we're going to be focusing on in this video, and then we'll learn how to use truth tables in the next video. So in order to symbolize arguments, recall an important distinction that I mentioned probably way back. That distinction is between statements that are atomic and statements that are compound. What is an atomic statement? An atomic statement is one that doesn't have any other statements that are part of it. Think about the word atomic. That word comes from the Greek, tomic, meaning to cut, whereas the a prefix meaning is like no. So no cutting, or you can't cut it. When we first named atoms, the idea was we thought atoms were the smallest thing. You couldn't get any smaller than an atom. You couldn't cut an atom or split an atom. Of course, we later found out we were wrong. We can split the atom. There are things smaller than the atom. But we named it atom because that's the thing we thought we couldn't cut, the smallest thing. Well, atomic statements are kind of like that. They are the smallest statements where you can't break them up into smaller parts and still have a logical statement or unit. So here are some examples of atomic statements. Shakespeare wrote Hamlet, roses are red, toilet paper is hard to find. So there's a very simpleness to these statements where you can't break them up in or pull out logical features of them and still have them make sense. Now let's symbolize atomic statements. Atomic statements are symbolized simply by a capital letter. So we'll use S for that first statement, R for roses are red, and T for toilet paper is hard to find. That's all there is to symbolizing atomic statements, just a capital letter. So that's atomic statements. Now let's look at compound statements. Compound statements are a little bit more complex, as the name might suggest. Compound statements consist of an atomic statement plus something else. Or more formally, we could say a compound statement is a statement that has at least one atomic statement as a component. It's an atomic statement plus logical operators or more atomic statements somehow joined in there. Examples. It's not the case that Shakespeare wrote Hamlet. So we took our original atomic statement from and we just added that extra thing. It's not the case that atomic statement Shakespeare wrote Hamlet. Here's a couple more examples. Roses are red and violets are ooh. Or either people are selfish or toilet paper is hard to find. When we highlight the atomic statements within these compound statements, you can see that these compound statements are just those atomic statements plus something. Except of course, you see in number 2, it's 2 atomic statements and they're joined together. So compound statements are basically just anything that's more than an atomic statement. How do we symbolize these compound statements? Well, we're going to take the capital letter for the atomic statement and then add something else. For instance, the first one, it's not the case that S, so we just use the letter for the atomic statement and then we're going to add something else. We'll symbolize this, it's not the case that, we'll symbolize that in just a moment. The other examples we have are and V, and then we have either P or T. These 3 examples are actually also examples of the things that are going to become our logical operators. But there are 2 more that we need to consider. We also have if-then, which will become a logical operator, and we have if and only if. We can symbolize the parts of these statements that are in white here with 5 new symbols that we're going to be introducing. These symbols we're going to be using for the rest of the course, the rest of the semester. So here are the symbols that we're introducing, and here's the names of the type of statements that they create when we add them in. So we have the tilde, which means not, and it's just a negation, so not S. We can just write that tilde. We also have just a dot that we're going to be putting between 2 things, and that's just and, or that creates a conjunction, right? R and V. We also have a V there, which is our next symbol. We put a V between 2 things, and that means either this or that, so either P or T, and that is how we write a disjunction. Our conditional, instead of writing if, then, we just put an arrow. So that's a nice simple one. You just draw that arrow, so you'd say if W, then X. And finally, we have a double arrow, which instead of a conditional, this creates a biconditional. This means, so B, if and only if H. This is basically equivalent to the conditional if B then H and if H then B. That's what the biconditional is going to mean, but more on that later. take a look at these examples of, on the left in white, you have correct symbolizations that we're going to be using in symbolizing arguments and statements. And then on the right, things that won't count as proper symbolizations for our purposes. So notice instead of Platys's per, we just want to use a statement letter. Notice that we want to use capital statement letters, not lowercase. So we'll just stick to capital for the letters representing our atomic statements. Also, we don't need parentheses around a statement by itself. We use parentheses in other places, but we don't need it just around a single letter. Also, then if you have tilde something, tilde m, you don't need parentheses, say around a single letter when you put a tilde out in front of it. If you had something more complex, then you would use a tilde, excuse me, to separate the tilde from the things it's negating. But when you have a single letter, you don't. Also, you have m.n. You don't need parentheses around them. So I wrote not needed here because typically in our formal languages for logic, and in fact in our book, we have a very precise way that's spelled out for writing what's called well-formed formulas, but we're not going to be using that really precise way. We're just going to be using the streamlined version, so you don't need parentheses there. Same thing with a conditional, the arrow. You don't need parentheses when you have, say, if m then n. And then finally, you have that more complex statement there. There, you do need parentheses. The bad example on the right, it's ambiguous. You have A or B, if that, then not C. But what's included in the if is the if including that whole thing A or B. So is it if A or B, then not C? Or is it saying A or if B, then not C? It's ambiguous between those two statements. But on the left, you have parentheses that disambiguate it. It clearly shows that the if part of the if then only includes the B. And then that whole if then conditional is part of the disjunction, the either or. If we had put the parentheses in a different spot, it would have meant something different. So when you have something like that with, say, 3 statements, you definitely want parentheses to distinguish exactly which statement that your statement is saying. Now let's look at a few things to be aware of as we symbolize. The first thing is that parentheses really matter. Parentheses are a form of punctuation in logic, and so we don't want to just leave them out or put them just wherever it looks good. They mean something different depending on where we put them. So take a look at these two compound statements. One has parentheses, the other does not. And because of this, they say something different. So we'll use B to stand for Christopher is a Buddhist, and we'll use H to stand for Christopher is a Hindu. Okay, what does the statement on the left mean then? Well, it means it is false that Christopher is a Buddhist or a Hindu. Okay, what does the statement on the right mean? Well, it means something totally different. It means Christopher is not a Buddhist or Christopher is a Hindu. So that's saying something different than the one on the left said. So you can see that parentheses do really matter because they change the meaning of statements. And that brings us to the next thing we want to be aware of, and that's the difference between a main and a minor logical operator. A main logical operator, it's the operator in a statement that governs the largest component or components in that statement. Whereas a minor logical operator, it governs smaller components within that statement. So for example, look at this this is the example we just had where, with the parentheses, not B or H. What's the main operator and what's the minor operator in this statement? The main operator is the not out front, whereas the V is a minor operator. The not is the tilde. It's negating everything else in the statement, everything inside those parentheses. So if you have the statement in parentheses, Christopher is a Buddhist or a Hindu, then that's saying it's not the case that that statement is true. It's not the case that Christopher is a Buddhist or a Hindu. So it's governing the most things, everything else. Whereas the or, it's just talking about the B and the H there. It's saying either B or H. It's not saying anything else about stuff outside the parentheses. So it's the minor operator. The minor is saying something about less stuff, whereas the main is saying something about everything. Take the other example without those parentheses. What's the main operator there? Well, the operator that's talking about everything else is now the V, the either or. Whereas now the not becomes the minor operator. So either, not B, or H. That V is main because it's talking about everything else. The not is not talking about everything. It's just negating that B now that it doesn't have parentheses. Another way to say this is the main operator has the largest scope, where scope is what the operator is governing. So the scope of the V in our second example is everything else in that statement, whereas the scope of the tilde, the not, is just B. The difference between the main and minor operators of a statement also change what type of statement that statement is. So the first example there is a negation, right? That's the type of statement it is. It's a negation of a disjunction. But our second example, it's not a negation. It's a disjunction of one thing that's a negation and one thing that's just an atomic statement by itself. So our first example is a negation. Our second example is a disjunction. It's the main operator you look at when you're trying to ask what type of statement is this. And another thing that we want to be aware of in symbolizing is that I'm not asking you to use the strict WFF rules, which means well-formed formula rules. That's how the symbolization is laid out in the book at first, and then they relax the strictness of the rules. So we're just going to jump straight to the relaxed version. There are two ways that our version is relaxed. You'll see that explained in the book on page 298 and 299. So the first thing that we relax is you can drop outside parentheses when they're at the outside of a statement, as long as that doesn't create ambiguity. So for example, we have, we saw before we had the statement M and in. Well, we don't need parentheses outside that whole thing because just dropping them frees up, it gets rid of some clutter and it doesn't change the meaning, right? So we can just drop those. However, if parentheses, dropping them does make a difference, we can't drop them. So as in our example where we had not, parentheses open, B or H, parentheses closed, dropping those parentheses would make a difference to the meaning of the statement. And it would, in this case, it wouldn't create ambiguity, but it would change the meaning of a statement. An example of where dropping the parentheses would create ambiguity, we saw before the statement A or, parentheses open, B arrow, not C, parentheses closed. If you drop those parentheses, that creates ambiguity. We don't know which statement it is. We don't know if the conditional part, B arrow not C, we don't know if that's part of a disjunction, or the disjunction, the A or B, is part of a conditional. Could mean either way if we don't have those parentheses. So in that case, we cannot drop the parentheses. But basically the rule is if you can drop parentheses and it doesn't change the meaning, feel free to drop them. You don't need them. So that's one of the relaxations of strict rules that we're going to be following the relaxation. The second thing is the use of brackets. You can replace parentheses with brackets. The reason to do this is that it can make things less confusing. The idea is that you want to replace some of your parentheses with brackets and leave the others. So look at this example. We have a bunch of parentheses there, especially at the end. You just got a set there of like, 3 parentheses in a row. It might get confusing about what part of the statement is within another part of the statement. So one thing you can do is change maybe every other set of parentheses to brackets so that you can see which opening bracket matches up with which closing bracket. But that's just a relaxation that we can do for the sake of avoiding confusion. So feel free to do that as you see helpful. So the things listed are just things to be aware of as you're learning to symbolize. Now let's look at stylistic variants of the different types of logical operators, because we need to be able to recognize the different ways things are said and know which logical operator to use to capture what is said. So first, let's look at negations. Negations are probably the easiest to identify and see. So we'll use R as our atomic statement, standing for roses are blue. And if we have that tilde R, it's the negation of roses are blue. And there's a few different ways we could write that. Of course, you could just say roses are not blue. You could also say, and this is kind of the standard clear way to say it for logic, it is not the case that roses are blue. But you might also see it is false that roses are blue, or you can see roses fail to be blue. All 4 of those ways of speaking, they all mean the same thing in terms of logic. It's just the negation of roses are blue. And you would symbolize all 4 of those statements the same way. You would just have a tilde R. There might be other ways to speak in English. There's lots of other ways you can, I'm sure, think of to say the same thing. You can get creative. But those are just examples. We call them stylistic variants of negation. So whenever you see that, you want to write it, you want to symbolize it the same way. Tilde R, not R. Next, we have conjunctions. The dot. Typically, this is just going to be and. So K and S. We'll use K, Kelly likes Krispy Kreme, Stu likes Shipley's. And so you can put those together in a conjunction, the dot. So that's how you would symbolize if you see, of course, Kelly likes Krispy Kreme and Stu likes Shipley's. But of course, you could use the word but. So we recognize typically a difference between the word and but, right? And is just a simple, okay, both these things, but is introducing like a contrast, right? Like there's some kind of contrast going on. Kelly likes Krispy Kreme, but Stu likes Shipley's. And that seems different than using the word and. However, in terms of those statements' logical features, there's not really any significant difference in terms of its logical features. So that implied contrast is not really something we need to capture when we're just trying to capture the logical features. So we are just going to symbolize both those statements the same way. We'll use a dot for when we see and when we see but. There's other ways you'll see, so however, right? Instead of but, you could say however. That's maybe an even stronger contrast or something that is implied, but it's the same thing in terms of its logical features. It's just a conjunction. You're saying both these things, right? Kelly likes Krispy Kreme. You're stating that. You're also stating Stu likes Shipley, and you're just saying both those things, even if maybe there is an implied contrast or not. You could also, instead of a word right there in between the two statements, you could put, while Kelly likes Krispy Kreme, Stu likes Shipley's. Or you could say, although Kelly likes Krispy Kreme, Stu likes Shipley's. There are plenty of other words that we use in English that we're going to symbolize the same way. So you could have the word yet in there, nevertheless, even though, though. These are all, in terms of their logical features, equivalent to just an and, even though there's different shades of meaning there. The logical features, we're just going to use a dot in between those two statements when we see something like that. Disjunctions. Disjunctions, there's a few different ways you'll see this said. So let's use our example. We have C, Carol attends college, and we have J, Carol gets a job. You put those together with a V, and you'll see the standard way to say this. You'll have either Carol attends college or she gets a job. But other ways you might see this said, you could have an and or in there. That's going to mean the same thing. You might just have an or without the either. Same thing. But then now this one's pretty kind of hard to wrap your mind around perhaps, but unless. Unless is going to mean the same thing as either or. So Carol attends college unless she gets a job. And we'll talk more later, I think in the next teaching video perhaps, about why unless gets symbolized with a V, like an either or. Next, we have conditionals. Conditionals can be a little tricky sometimes depending on the stylistic variant. So you'll definitely want to spend some extra time here, making sure you get down these different stylistic variants and practicing learning to recognize them. So for example, we'll have the C arrow A, where C stands for Garfield is a cat, and the A stands for Garfield is an animal. So standard, of course, we have our if then, but instead we could have given that out front. So given that Garfield is a cat, he is an animal. But also this next one gets a little tricky because we switched the order of our statements in there. And we put that given still in front of our normal if part, but it comes second in the sentence. So there's actually a number of ways that in a conditional, the order of the statements can get switched around depending on what's going on. So you want to pay attention to that. Other ways you'll see a lot, especially examples in our book, assuming that Garfield is a cat. Instead of saying if Garfield is a cat. Or you could say provided that Garfield is a cat, or on the condition that Garfield is a cat. All three of these examples, be aware that the order of the statements can change, and you can just put that phrase like assuming that in the middle of the sentence. So instead of assuming that Garfield is a cat, he is an animal, we could say Garfield is an animal, assuming he's a cat, right? So you could switch the order that the two atomic statements come in if you change the other words like assuming that and put them in the right place. So just be aware of those. But I think a good tip to remember is just remember those phrases as other ways to say if. So assuming that is another way to say if, or provided that is another way to say if. That's how I got it down when I was learning it. Other examples, so we could just put the if in the middle of the sentence, right? And the if is introducing the if part of the statement. But here is probably the most tricky way of saying this, or stylistic variant. The only if. I would pay particular attention to only if. Whenever you see that phrase, make sure you know what's going on. if and only if are very different. They're basically opposites. So if you see that word all by itself, the next thing that's coming is the if part of the statement, which is the antecedent, right? But if you see that phrase only if, the next thing that's coming after it is the consequent, the then part of a conditional, not the if part. So Garfield is a cat only if he is an animal. That's just like saying if Garfield is a cat, then he's an animal. So be aware of that difference and pay particular attention. Other ways of saying it, sufficient and necessary conditions, those are popular in logic. So Garfield's being a cat is a sufficient condition for his being an animal. That's another way of talking about the if and then part of a conditional. The if part is always the sufficient condition. So it's the idea that if Garfield's a cat, right, that's sufficient enough for him to be an animal. But him being an animal, that's not sufficient for him being a cat, right? Because just because he's an animal, he could be another kind of animal, like a dog. That being an animal is not sufficient for being a cat. But being a cat is sufficient for being an animal. The flip side of sufficient is necessary. The necessary condition is always the then part of an if-then statement. So Garfield's being an animal is a necessary condition for his being a cat, right? There's no way that Garfield could be a cat without being an animal, right? If you're a cat, you're an animal. So being an animal is a necessary condition for being a cat. That's always the then part. The necessary condition is always the then part. Finally, we have biconditionals. Biconditionals is the standard way you'll see these written in English is the if and only if statement. So in our example, so we have Whitney is a teen if and only if she is from 13 to 19 years old. So remember that biconditionals are the combination of two conditionals. So this is equivalent to saying, say, if t, then y, and if y, then t. That's why it goes both ways. So the conditionals that we just saw a moment ago, the conditionals, remember I said pay attention to when you see that word if and if you see that word only if. They mean two different things. Well, here, this is the combination of both of them together. This is saying if and only if. So it's like two conditionals, one going one way, the other going the other way. And we'll talk more about biconditionals and why they are the way they are in the next teaching video. The stylistic variants you'll see just in case. That's the same as other ways of saying the biconditional. You also see is a necessary and sufficient condition for. So that's the combination, right, of what we saw with the conditionals, right? It's a necessary condition and it's a sufficient condition, right? So there's only a few ways that you'll see biconditionals. So those are the stylistic variants of the things you'll want to use the logical operators for. Whenever you see one of those, use the correct logical operator to symbolize it. Now, let's do some practice. We'll do a few practice problems from the book so we can practice symbolizing. These practice problems, they are going to be just like some of the questions that will be on the next exam. So if you learn how to do the practice problems from the book at the end of this section, that'll help you be in good shape for the exam. Let's do number 2. This is from 7.1 practice problem set C on page 300. So this practice part asks us to take a English statement and translate it or symbolize it using the logical symbols we just learned. And we're supposed to use the scheme of abbreviation that is provided. So here is number 2. Humans are animals if they are mammals. And this is the scheme of abbreviation we have. A stands for this atomic statement. M stands for that atomic statement. How are we going to symbolize this? Well, all we have here are, in our examples, we have this atomic statement and this atomic statement. And then we just got one word joining them, if. So we see that word if, and that's the only other word there. So we know this is going to be a conditional statement. So that means we're going to use an arrow to symbolize this. And now the only question is, do we put the A first or the M first? Well, the if is, that means it's introducing the if part of the statement. So that means this is the if part, the M, and the other part, the then part, is the A. So if humans are mammals, then humans are animals. And that's how we symbolize this statement. Let's do number 8 on the same page. We have this as what we need to symbolize. The statement, humans lack rationality, that's in quotes, is false. And the scheme of abbreviation we have H for humans have rationality. So how are we going to write that? Well, this is going to be a pretty short symbolization. We're just gonna have the letter H as atomic statement, and it's just saying that that atomic statement, humans have rationality, is false. So we're going to symbolize that as not. The negation, we'll use the tilde, not H. It's not the case that humans have rationality. That's another way of saying it. So that's the symbolization for this statement, this whole compound statement. Next, let's do the very next one, number 9. Here's our statement. Polly fails to be a parrot, provided that she cannot talk and does not want a cracker. We have a scheme of abbreviation with 3 statement letters for our atomic statements. Notice that there's no negations in here in our scheme of abbreviations. And there's a number of negations going on up here. We got fails to be, we got cannot talk, and does not want a cracker. So we're actually going to negate at some point all of our statement letters. But how are we going to symbolize this? Well, if you see the word provided that, hopefully you recognize that that is another way, a stylistic variant for conditional statements. Provided that, you should think if. This is like saying the if. So if, and now we have what comes next. We have she cannot talk. So Polly can talk. So cannot talk, that's going to be the negation of T. So we have tilde T for this part right here. And we also have and does not want a cracker. So we're going to have the negation of C. But what's going on there? There's a conjunction, right? We see the word and. So there's a conjunction in there. And we also, if this is the if part, if she cannot talk and does not want a cracker, this is the then part. So we're going to put the arrow. That's if all of this, then Polly fails to be a parrot. So we're going to write not P, or tilde P for the negation of that. But we are still missing our parentheses. All of this is the if part. We want to put our parentheses around this. Otherwise, it's ambiguous. If instead we had put parentheses in a different spot, say like this, then that would have meant something different, right? It would have just been saying Polly cannot talk, and if Polly does not want a cracker, then Polly fails to be a parrot. But that's not what our original said. The best way to symbolize it is going to be like this, right? This is all the if part. Another thing that you don't want to have is you don't want to read this part is just a tag on. I'll show you what I mean. So if not T, then not P, and not C, right? That, I think, would be a misinterpretation of our original statement, right? That's reading this, instead of having the parentheses of that whole thing being the if part, it's just saying, right, this is the then part, this is the if part, so this is a whole conditional, and then this is just an add-on, right? And does not want a cracker, and doesn't want a cracker. But I think that is a misinterpretation, right? The way this says she cannot talk and does not want a cracker, that sounds like that whole thing is part of the if part, that condition. So this is how you want to symbolize it. Awesome. Let's do number 12, same section, but this is going to be on the next page, page 301. So we have our statement, Al wins only if Ed does not win, and Ed wins only if Al does not win. Our scheme of abbreviation, we only got 2 letters standing for our atomic statements there, and they're repeated a couple times there. What are we going to do? Well, we've got different logical operators. You see the word only if. You should recognize that as this is going to be there's going to be a conditional, and this is going to introduce the then part. We also have and, so we're going to use a dot. There's a conjunction going on, and then we have only if again. So it's like we got 2 conditionals. We also got some negations in there, right? We have Ed does not win, and we got Al does not win. So I think that's all the logical operators in there. So now we just got to figure out how to do it. So we got Al wins only if Ed does not. So that's going to be a conditional. So we got A arrow not E. But now we got an and. So an and is going to be a dot, right? And over here we have Ed wins only if Al does not win. So that's another conditional. It's going to be if E then, so arrow, not A. So tilde A. But of course we need our parentheses. Where are we going to put them? Well, the proper way to read this is as these 2 conditionals on either side of an and, right? Because it's giving us this conditional and that conditional. So, question, what is the main operator of this statement? That's going to be the dot, not either of the arrows, because the dot governs everything else. It has everything else in its scope. A dot needs 2 things, one thing on one side and one thing on the other. It's got and so the left thing is this, the right thing is that. Everything else is in its scope. So the dot is the main operator. Everything else is the minor. The next one we'll do, let's jump to the next section. This is further down the same page, 301. Instead of 7.1c, we're doing 7.1d. So this is number 8. We're still doing the same thing. So neither Smith nor Jones wins if there is a tie, but Jones does not win given that Smith wins. We've got 3 statements, atomic statements in there. So we got Smith wins, Jones wins, there's a tie. What are we going to do? Well, what do you think the main operator here is? The logical operator that covers everything else well, we got neither Smith nor Jones, so there's some negation going on, but that's not talking about everything else. It's just talking about some small components. We got an if in there, so we know there's a conditional, but it looks like the conditional ends, right? Neither Smith nor Jones wins if there's a tie. But now it looks like it's saying something else, something new outside of the conditional there. So this conditional is not going to be the main operator. We've got but Jones does not win given that Smith wins. Well, it looks like, so but what kind of symbol, logical operator does that suggest? It suggests a dot, right? The and. It's another way to say and. So we're going to have an and it looks like that's actually the main operator because we've got the and in between this conditional and then this conditional. So it looks like we've got a conjunction of 2 conditionals going on. So how are we going to symbolize the first part of that, the left side? Well, neither Smith nor Jones wins if there is a tie. So we've got a conditional. We see the word if. This is going to be the if part, the left side of the arrow. So there is a tie. So that's T, right? So that's the if part. If there is a tie. The then part is this. Neither Smith nor Jones wins. But it's complicated. It's not just a single letter. So we're going to need to use some parentheses and say neither Smith nor Jones wins inside these parentheses. Well, to do that, we need S and J, and it looks like it's negating both of them. So we have not S and we have not J, and it's saying and. So it says not S and not J. So we'll do that. Not S and the dot, not J. So now this part of the statement says if there is a tie, then Smith does not win and Jones does not win, or neither Smith nor Jones wins. Good. So now we have the left side. Now we need to do the right side of the but. So now we have Jones does not win given that Smith wins. So given, that is a stylistic variant. That's like saying if in a conditional. So this is like an if. If, so given that is like if Smith wins. So we got S for Smith wins, and that's the left side of a conditional. The then part is going to be this. Jones does not win. So that means we have not J. We still need some parentheses, right? Just like we need a few parentheses. We need to put parentheses around the if-then part, right? But we still have an ambiguity going on because we have an and here and an arrow there. Right now, it leaves open, is all of this to the right of the arrow? Is that all part of the then part? Or is just this part the then part and all of this is to the left? So that's actually right? We said the and is the main operator. So we need parentheses around all the stuff on the left of the dot, the and. Awesome. We got a conjunction This part is really complex. This is still complex, but not as complex. But that's how we symbolize that one. Let's do one more example of this symbolizing for this video. So we'll stay in the same section, but this will be on the next page, 302, number 12. Our statement, compound statement, either Floyd Mayweather, screwed that up, either Floyd Mayweather Jr. wins or Manny Pacquiao wins, but not both. We've got two atomic statements, or letters. So how are we going to do that? Well, it looks like we have an either or, right? That's pretty straightforward. So we're going to use the V. We'll have an either or. So either Floyd Mayweather Jr. wins. That's F. Or Manny Pacquiao wins. That's M. And then we have but not both. What do we do with that? Well, looks like that's adding on to what was said here. So we'll put that in parentheses. The but stylistic variant of and. So and, but not both. Well, what does that mean? So not both Floyd Mayweather wins and Manny Pacquiao wins. What would both look like? Well, it'd look like both of these guys win. So F wins and, well, so what would it be? F and M, that's both, right? But it says not both. So we need to negate both. This would be both, but not that's not both. So that's how we symbolize that. You don't want to make the mistake, instead of writing this part like that, you don't want to write not F and not M, right? You don't want to write it like that, because that means that while this says not both, this says not F and not M, or Floyd Mayweather Jr. does not win and Manny Pacquiao does not win. Nobody wins. But this is saying they don't both win. So they don't both win. This is saying nobody wins. So that's wrong. You don't want to do that. Awesome. So that's the last example for the video practice. But if you want more practice, definitely check out the extra videos that I'll be posting. I'll be doing some more practice symbolizing. And other than that, there will be a quiz that's pretty short and easy to complete based off of this section of 7.1, Symbolizing for Truth Tables. And I will be posting the first homework, online homework, coming soon. So stay tuned for that. The next video is going to be about setting up truth tables and how they work, 7.2. So stay tuned for that. Thanks for watching, everybody, and I'll see you in the next video.